Okay. So, wait lang. Nakikita ba yung sinishare ko na whiteboard? Okay naman. Okay, so let's start our discussion. So, we will begin with Module 07. Now, what is Module 7 about? So, kapag sinabi natin na Module 7, ang topic natin dito is how to write isotopic symbol and ionic notation. Bago tayo mag-start doon, kailangan muna nating i-review kung ano yung alam natin about ions and atoms. So, kapag sinabi natin na atoms, what do we mean by atoms? This is the, feel free to unmute yourself and then answer the question, okay? Anytime. So, what do we mean by atoms? What are atoms? Yes, Justin.
It is po the smallest particle of a chemical element po.
Okay, correct. So kapag sinabi na atom, ito yung pinakamaliit na nagre-represent sa isang element. Okay? So kapag sinabi kasi natin na atom, this is the smallest unit na kung saan nagbi-build siya ng mga matter. So yung mga matter natin, kapag inisa-isa natin yung mga particles niya, we will come across yung kanyang tiniest particle, which is the atoms. Okay. Next is, ano ang pinagkaiba ng atom sa ion? Before we go there, let us have an example of this atom. So we have hydrogen atom. Now, napakahaba ng hydrogen para isulat ng minsanan. So, people have devised a way in order to make this shorter. So, gumawa tayo ng symbol which is, the symbol for hydrogen is H. How many types of atoms are there currently? Ilan sa tingin nyo ang alam natin na iba-ibang uri ng atom? There are 118. Paano natin nasabi na 118? That is because there are 118 known elements in the universe. Known elements. Kasi yun pa lang yung nadi-discover natin or na produce natin. Okay? Next. So one of those 118 elements is hydrogen. Okay. Now, si hydrogen, meron tayong ginagamit na symbol in order to represent hydrogen, which is letter H. Ang tawag doon sa pag-represent ng isang element using one or two letters only, we call them atomic symbol. So for the symbol for hydrogen is H. What about for chlorine? What is the symbol for chlorine? Anyone? Okay, it is Cl. What about for nitrogen? It is N. Kung mapapansin ninyo, kung ano yung kanilang first letter or first two letters, yun yung nagiging symbol nila. However, there will be instances na kung saan yung symbol nila ay malayo sa kung ano yung pangalan nila. Let's say we have sodium. For sodium, ang symbol niya, number 11 sa periodic table, it is Na. What about for tungsten? The symbol for tungsten is W. Bakit kaya ganito? Unmute yourself, please. Napaka-responsive ng mga ating viewers. Bakit kaya ang symbol ng sodium is Na, sa tungsten, W? This is because, yes, correct, si Jesseline. Hango sila sa kanilang Latin name. The Latin name for sodium is natrium. The Latin name for tungsten is wolfram. Kaya W. Can you give me one symbol na kung saan yung kanyang pangalan ay malayo sa kanyang symbol? Unmute yourself. Okay, John Ray, AU gold. Julian, silver is AG. Bakit AU si gold? Wala namang A, wala namang U si gold. Kasi ang Latin name ni A ay ni gold is aurum. For silver, wala namang A sa silver, wala din namang G, pero bakit AG? That is because the Latin name for silver is argentum. Doon nang galing yung AU tapos yung AG. Bakit hindi AR si silver? Kasi AR nakuha na. Na kay argon na si AR. Kaya ang kinuha na lang yung next letter kaya naging AG. Okay? Now going back. Each of these atom is composed of subatomic particles. Kapag sinabi natin na subatomic particles, ito yung kung ano yung gumagawa sa atom. We have three subatomic particles. These are proton, electron, and neutron. Now, itong tatlong subatomic particles na to, malalaman natin ang kanilang bilang sa bawat atom, knowing only their knowing only their atomic number and atomic weight. Pero bago tayo dumako doon, alamin muna natin kung ano yung proton, kung ano yung electron, at kung ano yung neutron. We have already studied this before in module number 4, I think. Tapos maliban doon, ginawa natin ito sa ating major performance task. So, what do we know about protons? Okay, tama
Positive
si...
charge, sir.
Okay, correct. Positive charge. Banggitin ko lang yung mga sagot na hindi ko nabasa kanina. We have potassium, which is K, lead, Pb, iron, Fe. Bakit kaya K si potassium? That is because the Latin name for potassium is kalium. For lead, Pb kasi plumbum. For iron, Fe kasi ferrum. Tin is Sn kasi stannum ang kanyang Latin name. Okay. So ano ang alam natin sa proton? Kagaya nabanggit kanina, they are positively charged. So this is, dito ko lang sa gilid ilagay. Nagkamali ako ng pagkakalagay kanina. So una, it is positively charged. Kay electron naman, ano ang kanyang charge?
Negative.
Correct, negative. For neutron, ano ang kanyang charge?
Neutral.
Neutral.
Neutral. So 0. Now, these subatomic particles have what you call symbols. For proton, the symbol is small letter P na may positive na superscript. For electron, it is E na may negative na superscript. For neutron, it is N na may 0 na superscript. Next, what about their location? Are they inside the nucleus or outside the nucleus? For proton, is it inside or outside?
Inside.
Inside, sir.
Okay, correct. Inside. So it is inside the nucleus. Electron is
Also inside, sir.
Outside.
outside siya.
Oo nga, sorry.
Okay, so kapag electron nasa outside siya, si neutron ay nasa,
Inside.
okay, correct, inside. So since si proton tapos si neutron ay nasa loob ng nucleus, ang collective term sa kanilang dalawa is nucleon. Ibig sabihin ng nucleon, this is a collective term for proton and neutron. Okay, next. What else do we know about these subatomic particles? Sa proton, next is we're going to compare their relative mass. Pag sinabi natin na relative mass, ito yung i-compare natin yung mass ng isang subatomic particle to another subatomic particle. So, ang gagawin natin na basis is yung proton. So, ilang proton ang kinakailangan para magkaroon ng mass ng isang proton? How many protons do we need to have the same mass as one proton? Akala nyo trick question, no? Pero syempre, isang proton lang ang kailangan para maging equal yung mass niya sa another proton. Ilan naman na electron ang kinakailangan for it to have the same mass as one proton? How many electrons do we need to have the same mass as one proton? We need 1,837. Some sources say 1,840 kasi ni-round off na niya. So, kailangan natin ng 1,837 na electrons para magkaroon lang ng equal na mass sa isang proton. Ganun kaliit yung mga electrons natin. Okay? Next, for neutron, ilang proton ang kinakailangan for us to have the same mass as one neutron? It is 1.001. Yung iba nakalagay is 1.01. Okay lang. Since we are only making use of relative mass, representation lang siya, tanggapable yung yan. Gusto lang natin na ipakita na ang neutron ay may halos the same mass sa isang proton. Mas mabigat lang ng napaka-slight si neutron as compared to proton. So ibig sabihin, kung si proton ay kasing bigat lang din ni neutron, tapos lahat sila ay nasa nucleus, that means all, or sabihin natin na almost all of the weight ng isang atom ay nasa nucleus. Okay? And then lastly, ano ang impact nila? Si proton, kapag nabago yung number, mababago na yung type of element. Bakit kaya? Kasi ang number of proton ang nagdidictate kung ano magiging element siya. Kung isa ang bilang ng proton niya, then that is hydrogen. Paano kapag ang bilang ng proton niya ay 3? Then that is lithium. Yung mercury, ang number of protons niya ay 80. Pag binawasan mo ng isa yung proton niya, hindi na siya mercury. Magiging gold na siya. So doon nakadepende ang chemical properties tapos ang identity ng isang element. Nakadepende siya sa number ng proton. Okay? So the number of proton dictates the element. Pagpasensya nyo na yung sulat ni sir. Sa chalkboard maganda ang sulat ko, tapos sa whiteboard pangit din. Hindi consistent. What about electrons? So kapag dinagdagan natin or binawasan yung electron, hindi mababago yung element. Kasi hindi naman doon nagre-rely yung kung ano magiging element siya. Kapag binago natin yung number of electrons, ano ang mangyayari? Anyone? It defines, okay, correct, Kyle. It defines the charge of the element. Yes, Erickson. Any
Sir,
additions?
magiging ions po, sir.
Okay, correct. So dito nakadepende ang kanyang charge. So since mababago yung kanyang charge, pag sinabi ng charge, it could either be positive or negative. So kapag nabago natin yung number of electrons, magiging ion na siya. There are two types of ions. It could either be positive or negative. Pag positive, we call that, anyone?
Cation.
Okay, correct. Cation. For negative, it is anion. So kapag nabago natin yung electron or yung bilang ng electron sa isang atom, mababago yung kanyang charge. It will become either positive kapag nabawasan siya ng electron or negative kapag nadagdagan ng electron. What about neutron? Kapag binago natin yung number niya, ano ang mangyayari? Machi-change ang kanyang stability. Yung neutron, yung isang atom kasi, may iba-iba siyang uri ng isotope. When we say isotope, same element siya, pero magkakaiba yung bilang ng neutron. The more neutron that an atom has, the more unstable the element becomes. Okay? So, kapag nadagdagan yung neutron, kapag nadagdagan, nagkakaroon ng instability. So, yun yung dahilan kung bakit nagkakaroon tayo ng decay ng mga atoms. We call that nuclear decay or pwede din siyang tawagin na half-life. Pag-aaralan natin yan in physics. Okay, so now we have the breakdown of the three subatomic particles. Balikan natin yung mga elements natin. So makikita nyo sa periodic table of elements, meron yung mga nakaboxes dyan. For example, ito yung box. Let's say lithium. Sa lithium, meron ka makikitang number dito na 3, tapos meron din nakalagay na 7. Or yung ibang nasa periodic table of elements, dito nakalagay yung 3, dito nakalagay yung 7. Okay. Tapos nakalagay sa baba yung pangalan, lithium. So, this one is the name of the element. Yung Li, ano naman yung Li? This is the symbol or atomic symbol. Yung mas mababa na number, alin na mas mababa, yung 3 or yung 7? Which one is the lesser number?
3.
Okay, correct. 3. So this is 3. Kung ano yung mas mababang number, yun yung kanyang atomic number. Okay, excuse. Next, yung mas mataas na number, we call that the atomic weight. Sometimes, tinatawag siyang atomic mass. Sometimes, tinatawag siyang mass number. Okay? Now, using this detail, malalaman natin kung ilan yung subatomic particles ng bawat element. Okay? So, si hydrogen, ang kanyang atomic number is 1. Ang atomic weight niya rin ay 1. So, paano natin malalaman kung ilan ang bilang ng proton ng hydrogen? Kung ano yung atomic number, yun yung bilang ng proton niya. So the number of proton is equal to the atomic number. Since ang atomic number ni hydrogen ay 1, then therefore the number of proton is 1. Bakit hindi pwedeng 2? Bakit hindi pwedeng 3? Kasi nga 'di ba, yung number of proton ang magdidictate ng kung anong element siya. By the way, guys, kung mabilis ako magsalita, pakisabi lang, unmute yourself, and then sabihin nyo na mabilis ako magsalita because I have this tendency na magdire-diretso na magsalita. Next, how many electrons do we have? Anyone? Sa periodic table kasi natin, it is assumed that they are stable. Maliban dyan, it is also assumed that they are electrically neutral. So that means they have no charge. So kung ilan yung bilang ng proton, and that since they are neutral, yun din yung magiging bilang nila ng electron to balance it out. So since 1 ang ating proton, then since wala din siyang charge, we are going to assume that ang bilang ng electron niya ay isa rin para ma-balance out, para mawala yung charge. Okay, next, what about neutron? How many neutrons does hydrogen have? Kapag sinabi natin na neutron, it is equal to the atomic weight minus the atomic number. Kasi kapag sinabi kasi natin atomic weight, ito ay pinagsamang proton plus neutron. So para makuha natin yung number of neutron, ibawas natin yung number of proton doon sa atomic weight. Okay? So dito sa hydrogen, 1 ang atomic weight natin, tapos 1 din ang number of neutron natin, kaya 1 minus 1 is 0. So that means, okay, yes, wala tayong neutron sa hydrogen. What about chlorine? Tingnan nyo, ano ang kanyang atomic number? Number 17 sa periodic table. Second row, second column. Second to the last column. Ano ang kanyang atomic number? 17. So that means how many protons do we have sa chlorine?
17.
Okay, 17. For electrons,
17 po.
okay, 17. For neutron,
18 po.
okay. Paano naging 18? Atomic weight minus the atomic number. So, 35 ang number ni chlorine. In the number of neutrons, nag-kwan tayo. Nag-round off tayo to the nearest whole number. So, 17 ang kanyang atomic number. 35 ang kanyang atomic weight. So, 35 minus 17, that is 18. For nitrogen, number 7 sa periodic table. Ilan ang kanyang proton?
7.
Okay, 7. For electron, it is also 7. For neutron, ang atomic weight ni nitrogen is 14. Ang atomic number niya ay 7. So, how do we get the number of neutron? 14 minus 7, kaya magiging 7. Next, last na to si sodium. Na, number 11 sa periodic table, nasa first column, pangatlong row. Ilan ang kanyang proton?
11.
11. For electron, it is
11.
11. For neutron, it is 23 ang kanyang atomic number. It is 12. So, those are the number of subatomic particles each element has. Doon natin malalaman using their atomic number and atomic weight. Now, there will be instances na magkakaroon ng charges. Okay? So, let us have, ano kayo yung pinakasimple? Lithium as an example. So, si lithium, ang kanyang bilang ng proton ay 3. For electron, 3 rin kasi neutral siya. For neutron ay 4. Kasi 7 minus 3 is 4. Si lithium na normal yan. Paano kaya kapag naging lithium positive siya? Positive 1. In charges, kapag 1, kahit na wag nang lagyan ng value. Basta maglagay ka lang ng positive, it is understood na 1. So, ilan ang bilang ng proton ni lithium? Na positive ang charge. In charges, wait lang, sandali. Bago tayo mag-proceed, in charges, ano ang nababago? Anong subatomic particle ang nababago? Proton, electron, or neutron?
Electron po.
Okay, correct. Electron. Bakit hindi pwedeng mabago yung proton? Kasi? Because? Hindi pwedeng... Okay, kasi same siya sa atomic number. Ano pa? Another reason is, yung mga protons kasi
Nasa
natin,
loob po ng nucleus po.
okay, yes, nasa loob siya ng nucleus. So, ibig sabihin, in any chemical reaction, we're talking about chemical reactions here, in any chemical reaction, the number of proton does not change. It remains the same kasi nasa loob siya ng nucleus. It is being held together with the neutrons by the strong nuclear force. So hindi siya agad-agad nababago, hindi siya agad-agad nagkakaroon ng changes in numbers of neutrons or protons. Si electrons, siya yung nababago lagi sa chemical reaction kasi siya yung nasa labas. Tapos malayo siya sa nucleus. Kaya ang nababago lang sa charges natin ay ang kanilang number of neutrons. So for lithium, since 3 ang kanyang atomic number, 3 pa rin ang kanyang number of proton. Hindi pwedeng maging 2 yung number of proton or 4 kasi kapag binago natin yung number of proton, mababago na yung element. For electron, ilan ang electron niya? Okay, kung ang charge natin ay positive, that means nabawasan siya ng electron kasi remember that electrons are negative. So, what number ang pwede nating i-minus sa proton para lumabas na magiging positive 1 ang kanyang charge or magiging positive 1 ang sagot? It is, yes, correct, 2. Nabawasan siya ng isang negative sa buhay niya kaya naging positive 1 siya. Neutron remains the same at 4. Next, what about aluminum? A neutral atom of aluminum will have 13 proton, 13 electron, 14 neutron. Ayos sumulat. Ayun. 14 neutron. What about an aluminum ion? An aluminum ion has a charge of positive 3. Ilan ang maging proton niya?
Sir.
Okay,
13 po.
13. Ang electron ay magiging
10 po.
10. Ang neutron will remain at 14. So yan yung mga charged atoms natin or we call them ions. What about nitrogen? Nitrogen, kapag naging ion siya, maraming klaseng ion ng nitrogen. Pero in nature, the most abundant is negative 3. So si nitrogen na negative 3, ang proton niya ay 7. Kasi 7 ang atomic number niya. Ilan ang magiging electrons niya?
10.
Okay, correct. 10. And then we have neutron na 7 pa rin. So those are your charges. Okay? Madali lang ang module number 7, di ba? Do you have any question regarding module number 7? Any question regarding module number 7 bago tayo mag-proceed? So yung atomic weight po ba kailangang i-round off po siya sa whole number? Okay, kapag nagbibilang lang tayo ng number of subatomic particles like protons, electrons, and neutrons, it would be best na i-round off na lang natin siya sa whole number. Pero kapag nagko-compute tayo, ng number of moles, atomic weight, ganon, ay ng number of moles, number of molecules, or any other, i-round off natin yung nasa periodic table na atomic weight into 2 decimal places. Okay? So rule natin yan para pare-pareho tayo ng computation na lalabas. Sir, kung pipili kami ng atomic mass pero dalawa yung andoon, ano ang pipiliin? Yung mas mababa or mas mataas? Now, para same tayo ng computation, kukunin natin yung mas mababa. So for example, we have chlorine. So si chlorine, dalawa yung nakalagay na atomic mass niya. That is 35.46. I don't remember. Tapos 446 ata or 445. Paki-check kasi wala akong hawak na predictable ngayon. I'm only getting this off from my memory. So, dito kasi sa chlorine, dalawa yung atomic weight na nakalagay. Yung isa mababa, yung isa mas mataas. Now, kung ano yung mas mababa, yun yung mas abundant kasi in nature. Kaya ang kukunin natin yung mas mababa, sorry. Kukunin natin yung mas mababa. Tapos, i-round off natin siya into 2 decimal places. So this will become 35.45. So that means in all computations natin, ang kukunin natin ay yung mas mababa, tapos i-round off natin sa nearest 2 decimal places. Okay, talusable? Any other question? I think in-announce ko rin yun sa Google Classroom, tapos pina-screenshot ko sa mga secretary to post sa GC natin. Kung wala ng question, mag-heart message dito sa ating chat box. Next, let's go to module number 8, which is about calculating the average atomic mass. But before we go there, let us have a review on what isotopes, isobars, and isotones are. So mag-review muna tayo sa different types ng isang element or ng isang atom. So for example, si hydrogen. Hydrogen has 3 isotopes. Now, when we say isotopes, we have the same atomic number, but different atomic weight. So hydrogen has 3 isotopes, H1, H2, and H3. H1 is called protium, H2 is called deuterium, H3 is called tritium. So same lang sila ng hydrogen, pero magkakaiba ang kanilang atomic weight. Bakit kaya? Kasi, bakit magkakaiba ang kanilang atomic weight? Saang subatomic particles sila nagkakaiba? Yes. Okay. Okay, correct. Nagkakaiba sila sa number of neutrons. For hydrogen na H1, ang number of neutron nito ay 0. So, 0. For H2, ang number of neutron niya ay 1. For H3, ang number of neutron nito ay 2. So sa kanilang tatlo, sino yung i-expect natin na pinaka-stable? Hindi sila nagre-readily undergo ng decay. So kung sino yung pinakamababa na number of neutrons, siya yung pinaka-stable. Now in this case, si H1 ang pinaka-stable na isotope ng hydrogen. So that is what we mean by isotopes. They have the same atomic number, they have the same number of protons, nagkakaiba lang sila sa kanilang atomic weight because they have different number of neutrons. What about isobars? I think you will encounter this especially in engineering. Isobars and isotones. Pag sinabi naman natin na isobars, they have different atomic number, but same atomic weight. So, ano ang i-expect natin sa isobar? Since they have different atomic number, that means they will be different elements. For example, let us have argon and calcium. Okay. So kapag sinabi natin na isobars, they have different atomic numbers, so we are going to expect that they are different elements. But they will have the same atomic weight. Ibig sabihin, kapag winay natin sila, they will have little to no difference sa kanilang weight. Kasi magka-equal lang yung kanilang mass number or atomic weight. In this case, si argon, 1840, tapos si calcium, 2040. Okay? So this is an example of an isobar. Magkaiba ang kanilang atomic number, pero ang atomic weight nila ay magkapareho. Now, this doesn't happen naturally. Nangyayari lang siya because we are rounding them off. Kapag sa bilang ng number of proton and neutron, ni-round off natin siya into the nearest whole number, kaya nagkakaroon tayo ng isobars. Okay? And then lastly, we have isotones. Now, when we say isotones, they are different atomic number, but same number of neutron. Okay? Mag-isip nga kayo ng example ng isotone. Tignan nyo nga sa periodic table of elements ninyo. Ano yung dalawang element dyan na kung saan magkapareho yung kanilang bilang ng neutron? What is... Okay. Phosphorus and then sulfur. Si phosphorus, ano ang kanyang atomic number? May nag-raise ang hand. Hindi ko nakita. Okay, Erickson.
Sir, vanadium tas chromium po.
Okay, vanadium and chromium. Unahin muna natin si phosphorus at si sulfur. Si phosphorus, 15 ang kanyang atomic number, 31 ang kanyang atomic mass. So, ang bilang ng neutron niya ay 16. What about si sulfur? 16 ang atomic number, 32 ang kanyang atomic weight. So, dito ay 16. So, they are isotones. Kasi magkapareho yung bilang ng number of neutron. For vanadium, it is 22, I think, ang atomic number. Tama ba?
23 po.
Ay, 23. Ang kanyang atomic weight ay
51 po.
51. Chromium is 24.
24.
Ang kanyang atomic weight ay
52 po.
52. So kapag kukunin natin yung number ng neutron ng vanadium, it is 28.
28.
28. For chromium, 52 minus 24, it is
28.
28. So that means they are isotones of one another. So those are the three types, are three, excuse, excuse, sorry. So those are the three different types. We have isotopes, isobars, and isotones. Now let's go to module number 8. Module number 8 discusses the isotopes ng different atoms. Tapos para i-compute natin, gagamitin natin yung isotopes na yun para i-compute natin kung ano yung ating average atomic mass. Okay, let's start. So how do you compute for the atomic mass in relation to percent abundance ng mga elements? So let us have an example. Chlorine. Si chlorine, meron siyang dalawang isotope. Chlorine 35 and chlorine 37. Now, kung meron kang 100 grams ng chlorine gas, mataas ang probability na mas mataas yung chlorine 35 kaysa sa chlorine 37. That is because the percent abundance or percent abundance for chlorine 35 is at 75.77%. So, kapag meron kang 100 grams ng chlorine gas, around 75.77% of that 100 grams is chlorine 35. Yung chlorine 37, mas mababa siya at 24.23%. So, this is their percent abundance. Okay? How do we compute for the average atomic mass? Simple lang. Ang gagawin lang natin ay we are going to multiply their atomic weight with their percent abundance para makuha natin yung kanilang average atomic mass. So this will become 35 times 75.77%. Ipag-add natin yan sa lalabas sa chlorine 37. So for chlorine 37, it is 37 times the percent abundance, which is 24.23%. Okay? Next, calculator. So 35 times 75.77%. This is calculator. Anyone? $26.52. For chlorine 37, so 37 times 24.23%. So this will become 8.97. So ipag-add natin yan. So 26.52 plus 8.97. So it is 35.49 ang kanyang percent abundance. Now, pwede tayong magkaroon ng differences dito. Ang difference lang pero natin dito is nasa hundreds lang. Okay? So the average atomic weight for chlorine is 35.47. Talusable? Mga bata? Mga bata? Unmute yourself.
Yes, sir.
Kung naiintindihan
Yes,
or
sir.
hindi. Okay. Para alam natin kung mag-proceed tayo o hindi. So, ganun lang mag-compute ng ating ng ating average atomic mass. Kung ilan yung kung ilan yung kwan niya, kung ilan yung, what do you call this? Percent abundance niya, i-multiply lang natin sa kanyang atomic weight. tapos ipag-add natin. So for example, we have element X. Element X has 3 isotopes. Element X21, ang percent abundance niya ay 82.6%. Element X22, which is 10.32%. And then element X23. So wait lang. Which is at 7.08%. How do we compute its average atomic mass? The formula there is multiply the atomic weight of each isotope to its percent abundance and then ipag-add na lang natin silang lahat. Okay? So for this one, this will become 21 times 82.6%. So 21 times 82.6% is, pwede nyo rin idire-diretso sa calculator, yes.
$17.35.
Wait. Excuse. Sorry. Come again, ano na yun, anak? It is 17.35.
35 po.
Next, 22 times 10.32%. This is,
2.27.
okay, 2.27.
27 po.
And then lastly, 23 times 7.08%.
1.63% po. Ay,
It is,
1.63 lang.
ha? Nak, sinong kaaway mo? Okay, it is 1.63. Pag pinag-add natin yan, so 17.35 plus 2.27 plus 1.63, it is this is 21.25. So that means the average atomic mass for element X is 21.25. Okay. Talusable ba? Madali lang, di ba?
Yes, sir.
Okay. Paano naman kapag ang hinahanap natin ay yung kanilang percent abundance? What is the percent abundance of each of these isotopes of magnesium, for example? We have 3 isotopes of magnesium. So magnesium 1224, magnesium 1225, and then magnesium 1226. For magnesium 1224, out of 500 grams, nakakuha tayo ng 400 grams. For magnesium 1225, out of 500 grams, ang nakuha natin ay 50 grams. For magnesium 1226, ang nakuha natin ay 50 grams. So, ano ang kanilang percent abundance? Para lang tayong kumukuha ng percent. Ang unang gagawin natin ay kunin natin yung weight ng lahat ng ating isotope na magnesium. In this case, kapag pinag-add natin silang lahat, the weight becomes 500 grams. And then, i-divide lang natin lahat ng weight ng mga isotopes ng magnesium sa 500. Dahil tinatamad ako lang pwedeng gumawa nito, kayo hindi pwede. Attitude scissors, sasabihin nila. Di-divide ko siya sa 500 and then times 100 para maging percent. Next, 400 divided by 500 times 100, then this is 80%. Pa-mute ako na nung sasakyan. Ay, nung sound natin kasi yung tunog ng sasakyan. Next, 50 divided by 500 times 100. So this is 10%. 50 divided by 500 times 100. So this is also 10%. So this is the percent abundance of each magnesium isotope. Any question? Sir, saan po makikita ang percent abundance? Given yan na sa questions, kapag magbibigay tayo ng question, ibibigay natin kung ano yung kanilang percent abundance para hindi na kayo maghanap. Any other question? Mag-backread ako sa ating chat, baka may nalagpasan ako. Okay, so far wala naman. Kapag walang question sa percent abundance, mag-smile react, ay mag-smile emoji sa ating chat. Sorry. Napakadali, mga bata, di ba? Parang pang grade 1 lang yung math natin ngayon. Okay, let's go to module number 9. Module number 9 is measuring amounts of substance. Wait lang sandali. Bakit may percent composition sa review? Ang percent composition nasa module 11 pa siya. Let me check lang yung ating module, okay? Yung nag-vibrate. Okay. Percent composition is module number 9. Okay, let's start with module number 9. So module number 9 is measuring amounts of substances. Now, there will be instances wherein you have to determine kung gaano karami yung amount ng substance sa isang object. And what better way to represent this through percentage. Okay? So, paano natin malalaman kung ilang percent ang carbon sa table sugar? Paano natin malalaman kung ilang percent ang hydrogen sa asukal at ang oxygen? Paano natin malalaman kung ilang percent ang sodium sa chlorine kapag meron tayong table salt? So, this is how you do it, mga anak. So, for example, we have NaCl. Ilang percent ang Na dito sa NaCl? Ilang percent ang chlorine? Hindi porket isang chlorine dito at isa ang sodium, ibig sabihin 50-50. Yun na yung sagot. Hindi tayo ganun mag-compute ng percentage na sa percent composition. Okay? So, paano natin malalaman? Una, alamin ang bilang ng bawat element. So, we have two elements here. We have Na and chlorine. So, Na tapos chlorine. Ilan ang Na sa ating NaCl?
1.
Okay, correct. 1. Ilan ang chlorine naman sa NaCl?
1.
Okay, 1. Next, we are going to multiply them by their atomic weight. Okay? So, for Na, ang atomic weight niya sa periodic table, it is 22.98. Am I correct? Or 99?
Tama po, sir.
22.98.
98.
Lahat ng mga values sa kinukuha natin sa periodic table, kapag atomic weight, they have their own units. Ang unit nila ay grams per mole. Okay? So, since kinuha natin yung 22.98 sa periodic table, ang unit niya ay grams per mole. For chlorine, sorry, for chlorine, nasa number 17 sa periodic table, it is 35.45, correct?
Yes po, sir.
Okay, grams per mole. Next, i-multiply natin. 1 times 22.98. So, this is 22.98 grams per mole. Next, 1 times 35.45. This is 35.45 grams per mole. Next, ipag-add natin. So, this will become 58.43 grams per mole. So, ang na-compute natin ay 58.43 grams per mole. Now, this is the atomic weight or the molecular weight. Molecule siya kasi more than one element or more than one atom. Now, this is the molecular weight for sodium chloride. Okay? Ito yung bigat ng isang molecule ng sodium chloride. Now, we're going to divide yung individual values nila with the atomic weight of the entire molecule. So, yung sodium na 22.98, i-divide natin siya sa 58.43 grams per mole. So, this will become, so 22.98 divided by 58.43. So, this will become, sorry, times 100 para maging percent. Times 100. So, this will become 39.29%. So, ibig sabihin, sa sodium chloride, ang percentage ng sodium ay hindi 50-50. Okay? Kasi we take into consideration yung kanilang individual weight as an atom. So, kapag kinompute natin, yung Na, ang magiging percent composition niya ay 39.29. Si chlorine naman, yung original weight niya na 35.45 grams per mole, i-divide natin sa molecular weight ng sodium chloride. So this will become 35.45 divided by 58.43 grams per mole. And then times 100 para makuha yung percent. So 35.45 divided by 58.43 times 100, it will become 60.71%. So that is the percentage of chlorine sa sodium chloride. Talusable? Now, ano uli ang first step? Alamin ko ano ang chemical formula. For sodium chloride, it is an ACl. Next, alamin kung ilan ang atom ng bawat isang element. So, for sodium, since walang nakalagay na value dito, so it is considered 1. For chlorine, 1 din. Next, kapag nalaman na natin yung bilang ng atom sa bawat isang element, we're going to multiply it with their atomic weight. For Na, it is 22.98. For chlorine, it is 35.45. Tapos, imo-multiply na natin. Kaya lumabas dito ay 22.98 tapos 35.45. Pag pinagsama-sama natin, pag in-add natin lahat yan, we will get the total molecular weight of the substance. And then we are going to divide our individual atomic weight, each element, to the molecular weight of the substance. Kaya 22.98 divided by 58.43. Times 100, lalabas 39.29, tapos 60.71. Another example, H2O. How many atoms of hydrogen do we have? Yes, correct. 2. What is the atomic weight of hydrogen? Number 1 sa periodic table. It is 1.01 grams per mole. For oxygen, ilan ang, okay, for oxygen, ilan ang kanyang number of atoms? Okay, 1. Times the atomic weight of oxygen, it is 16 grams per mole. Kindly correct me kapag hindi tama yung aking mga atomic weights ha, kasi wala akong periodic table. I'm only getting this off from memory. So nakuha na natin yung bilang ng atoms sa bawat isang element, tapos i-multiply natin siya ngayon sa kanyang individual atomic weight. Next is to multiply them. 2 times 1.01, it is 2.02 grams per mole. Next, for oxygen, 1 times 16, it is 16 grams per mole. So what is the molecular weight of water? Ipag-add lang natin, this will become 18.02 grams per mole. Okay? Next, nakuha na natin yung ating molecular weight or yung weight ng buong molecule ng water. Para makuha natin yung kanilang percent composition, kailangan nating i-divide yung kanilang individual atomic weight sa buong molecular weight ng water. So divide by 18.02 grams per mole. Makakancel yung unit na grams per mole and then times 100. So calculator. Hindi ko man yung calculator ko. It is 11.21. I will be relying on you for the computation kasi hindi ko mahanap yung calculator ko. Next, 16 divided by 18.02 times 100, this is 88.79. So, 88.79%. Okay? Madali lang kunin ang kanilang percent composition. Okay, next. What about the percent composition of, medyo hirapan natin ng konti, calcium nitrate. So, this is calcium nitrate. Alamin natin kung ilan yung atoms na meron or ilan yung bilang ng atom ng bawat element. Okay. Now, bago tayo dumako doon, gusto ko muna na malaman ninyo kung ano yung coefficient, kung ano yung subscript. Pag sinabi natin na subscript, ito yung small numbers written beside the element. Kagaya nito sa water, yung 2. This is an example of a subscript. Yung number dito, imumultiply niya yung sarili niya sa element na nasa left side niya. So that means yung 2 dito ay para kay hydrogen at hindi yan kay oxygen. Kung sino lang yung nasa immediate left side niya, yun lang madidistribute yung number na 2. What about dito sa calcium nitrate? Si calcium, wala siyang subscript, wala siyang number dito, kaya si calcium, ang bilang ng element niya ay 1. What about for nitrogen? Si nitrogen dito, wala siyang nakalagay na subscript dito. Pero naka-enclose siya sa parenthesis tapos may 2. Okay? So yung 2, i-distribute natin, yung 2 na nasa labas, i-distribute niya yung sarili niya sa mga nasa loob ng parenthesis. So si nitrogen will become 2. Correct yung mga sagot ninyo. What about for oxygen? Ilan ngayon ang oxygen natin? Okay, correct. Si oxygen dito ay may 3. So that means 3 ang oxygen niya. Pero naka-enclose siya sa parenthesis tapos may 2. So that means 2 times 3, this will become 6. Okay, so yes, correct yung mga sagot ng mga sa ating chat box. So the number of oxygen is 6. Next, multiply them by their atomic weight. For calcium, hindi ko alam yung exact, pero ang alam ko 40 ang kanyang molecular atomic weight. Ano yung exact niya?
40.08.
Okay, 40.08 grams per mole. For nitrogen, it is 14.01. Tama ba?
Yes po.
Yes, sir.
Okay, 14.01 grams per mole. For oxygen, it is 16 grams per mole. Do not forget to write down the units. Lahat ng atomic weight, grams per mole ang kanilang unit. So 40 times 1, this will become 40.08 grams per mole. 14.01 times 2, so this is 28.02 grams per mole. What about oxygen? 6 times 16, this is?
96.
Okay, correct. 96 grams per mole. Kapag pinag-add lahat yan, this will be equal to
164.1.
164.1 grams per mole. Next step, divide the individual atomic weight with the molecular weight of calcium nitrate. So divided by 164.1 grams per mole times 100. So for calcium, 40.08 divided by 164.1 times 100 is hello?
24.42%.
24.42%. Ang nakalagay sa inyong module ay formula mass. Okay lang. Tanggapable formula mass or molecular weight or molecular mass. Kagaya ng sinabi ko dati sa ating chemistry, hindi siya kagaya ng physics, pwede nating gawing interchangeable yung weight at mass. Pero in physics, hindi pwede. In chemistry lang natin pwedeng gawin yun. Next, for nitrogen, 28.02 divided by 164.1 times 100, it is 17.07. Thank you. And then lastly, for oxygen, 96 divided by 164.1, 58.5. Okay. So all in all, this is our percent composition. Now, kapag pinag-add natin yan, it should be equal to 100%. Sir, bakit yung sa akin ang lumabas 99.99%? Sir, yung sa akin naman ang lumabas 100.01%. Mali po ba yun? Okay lang yun, tanggapable yung mga ganong sagot. Nagkaroon lang tayo ng differences sa rounding off, kaya nagkaroon tayo ng minor differences sa ating answers. Kapag nagkakaroon tayo ng differences, siguro mga 0.01 lang. So either 99.99 or naka 100.01% siya. Okay lang, tanggapable yung mga yun. Next, how do we know the molecular weight? Wait lang, kasama ba yun sa module number 9, molecular weight? Sorry. Empirical formula and molecular formula, kasama ba yun sa module 9? Okay, hindi pa. Sa module 11 yun. So, saka ko na i-discuss ang empirical at molecular formula. So, any question in module number 9 in getting the percent composition? Okay, thank you, Zaira. None. Okay, kapag wala ng question dito, then mag-sad react. Kapag may question, feel free to unmute yourself tapos ask the question or i-type kapag nahihiya. Ang weird nung sa'yo, Justin. Okay, so wala nang katanungan, kaya let's move to module number 10. So module number 10 is about counting atoms and molecules. Before we go there, let us have what mole is. So ang mole, meron siya mga shortcut. It could be MOL, tinanggalan lang siya ng E sa dulo, or small letter N. So this is the unit for mole. MOL or N lang siya. What do we mean by mole? So, ang mole kasi, isa siya sa mga fundamental SI units. For example, sa time, ang fundamental unit ay second. For distance, it is meter. For weight, it is, sorry. For weight, it is, I think it's kilograms, hindi ko siya maalala. What about for volume? It is liters. For mole naman, it is the fundamental unit or the SI unit of the amount of substance present in an object. So for example kasi, kapag bibilangin natin yung number of atoms doon sa isang substance, napakarami. Remember that tayo nga na tao ay gawa tayo sa trillions of cells, tapos yung cell na yun gawa pa sa billions of atoms. So paano tayo magbibilang, 'di ba? So ang ginawa na lang na instead of having to count napakaraming zeros para sa isang atom lang, we make use of mole. For example dito, let us make sense of this. Meron kang egg. So we have 12 eggs. Para hindi mo na sabihin na you have 12 eggs, we make use of 1 dozen. Para hindi mo na sabihin na you have 1,000 years to live, sasabihin lang natin na 1 millennium. Okay? So, ganun din sa mole. Ginagamit natin ang mole to measure ginagamit natin ang mole as an expression of the amount of substance given in an object. Okay? So how do we compute for the number of moles of each substance? Always remember this triangle. So nandito si weight in grams, andito si mole, andito si molecular weight. Okay? Lagi niyong tatandaan, maraming buhay ang nasisave nitong triangle na to. So kapag nawawala yung mole natin, ang magiging formula natin ay weight over molecular weight. Kasi di ba natatakpan yung mole? Nasa taas yung weight, tapos yung molecular weight nasa baba. So mole will become weight over molecular weight. The weight should always be in grams. Okay? Next, paano kapag nawawala yung weight? So magkatabi si mole, tapos si molecular weight. So since magkatabi sila, that means multiply. So weight in grams will be equal to mole times molecular weight. Okay? Next, paano kapag ang nawawala yung molecular weight? So weight nasa taas, si mole nasa baba. So this will become, molecular weight will become weight in grams divided by mole. So, ganyan lang. Kapag nagki-quiz kayo, lagi nyo lang tatandaan itong triangle. Okay? Next, let us have an example. You have 10 grams of NaCl. Gusto mong malaman kung ilan yung number of moles dito sa NaCl na to na meron tayong 10 grams. So how do we compute for the number of mole of 10 grams of NaCl? Okay? So NaCl is 10 grams. Next, nawawala ang mole. So it is weight over molecular weight. So Na is equal to 10 grams divided by ano ang molecular weight ni NaCl? Babalik tayo dito sa ating percent, sa may part ng percent composition. Wala, nawala. Ayun, si Na. Babalik tayo dito. Kung paano yung ginawa natin sa percent composition, yun yung ginagawa natin to get the molecular weight. Okay? So for Na, we have, how many Na do we have? Isa. For chlorine, ang bilang ng atom natin ay isa rin. I-multiply natin sa kanilang atomic number, atomic weight. So this is 22.98. This is 35.45 grams per mole. Grams per mole. So this is equal to 22.98 grams per mole. Tapos yung chlorine naman ay 35.45 times 1. This is 35.45 grams per mole. Kapag pinag-add natin yan, it will become 58 point 58 point asan na? 43. Ang hirap ng walang calculator. So now we have our molecular weight. So 10 grams divided by the molecular weight of 58.43 grams per mole. Cancel grams. You will be left with mole. So 10 divided by 58.43 is equal to, calculator please. Hello. 0. Okay, di ba meron tayong rules na pinost ko sa ating Google Classroom na pinay-screenshot ko sa mga secretary natin. Kapag mole ang hinahanap natin, ang gagamitin natin ay 4 decimal places. Okay? So, 1.0.1711. Okay. So, this will become 0.1711. Okay. So, that means we have 0.17 moles of NaCl in 10 grams of sodium chloride. Okay? Now, doon sa iba sa inyo, or I think doon sa video lesson from Urdaneta, ang ginawa nila ay ganito. You have 10 grams of NaCl, tapos convert siya sa mole. Ngayon naman, same pa rin yung formula natin. Using the triangle, nawawala ang mole, kaya it is weight over molecular weight. So weight divided by molecular weight. Ang ginawa nila dito ay Na, which is equal to NaCl, which is equal to 10 grams, times, ang ginawa nila na instead na 58.43 grams per mole, ang ginawa nila is in 1 mole of NaCl is equal to 58.43 grams of NaCl. Now this is the same as this. Paano mo nasabi, sir? Sasabihin nyo. Kasi 58.43 grams of NaCl over mole, ibig niyang sabihin niya na in 1 mole of NaCl, there is 58.43 grams of NaCl. So, ibig sabihin nitong nasa taas, sa bawat isang mole, kasi per mole sabi niya, di ba? So, sa bawat isang mole ng NaCl, we have 58.43 grams. So, it is the same as 1 mole NaCl over 58.43 grams NaCl. Pwede mong balik-balik rin ito. Pwedeng nasa taas yung grams, pwedeng nasa baba yung grams. Tapos, sinabi doon na since grams ang unit na nandito, dapat grams din yung nasa baba. So, alin dito ang gagamitin natin na denominator? Itong nasa baba kasi para maging same yung unit ng grams para makancel. So, 58.43 grams of NaCl in 1 mole of NaCl. So, cancel grams. So, 10 divided by 58.43 times 1, we will have the same answer. This will still be equal to 0.1711 mole of NaCl. Gets kung paano kunin yung number of moles? Okay. So, madali lang siya. Basta alam mo lang itong triangle na to, masisave na ang iyong score sa pagko-compute sa number of moles, number of weights, tapos sa molecular weight. Sir, paano naman kapag ang binigay ay mole? Tapos kailangan namin kunin yung kanyang molecular weight. Kunin ang kanyang weight in grams. So for example, we have 2.58 mole of H2O. How many grams of H2O is there? So, ito ang ating given. Ko-compute natin para makuha yung number of grams. So, using our formula dito sa triangle, using this, ang nawawala ay weight, di ba? So, magkatabi ang mole tapos molecular weight. So, that means i-multiply natin yung number of mole sa molecular weight. Okay? So, this is the number of mole. 2.58 mole of water times what is the molecular weight of water? So si H2O, si H ay dalawa, si oxygen ay isa. Times the atomic weight. So this is 1.01 grams per mole. Nasa periodic table yan. For oxygen, it is 16 grams per mole. Pagpasensya nyo na yung sulat ni sir. This will become 2.02 grams per mole. This will become 16 grams per mole. So all in all, the molecular weight for water is 18.02 grams per mole. So, i-multiply na natin siya ngayon sa number of mole. So, 18.02 grams per mole. Cancel yung mole kasi mole yung ating numerator dito tapos mole yung denominator dito kaya makakancel. You will be left with grams. So 2.58 times 18.02 is equal to 46.49 grams. Okay, thank you. So this is 46.49 grams of water. So that means sa 2.58 mole of water, we have 46.49 grams of water. Any questions so far? Okay. Kung wala ng question, kayo ay ah ganyan na react. Hindi ko alam kung anong tawag dyan. Dapat, sorry. Nawiwirdohan lang ako sa... Sorry. Erickson, kwan nga, sample nga palagayahin ko. Hindi pa ako nakakarinig ng ganyan talaga eh. Paki-unmute.
Sir?
Oh, paano yun? Sabihin mo nga kung paano with
Ganun,
feelings.
sir.
Wag na pala, ayoko pala. Next time na lang, saka na kapag pag, pagpa-graduate na kayo. Para minsan na yung kahihiyan na gagawin ko. Ganun pala yung sound na yun. Okay? Okay. Okay. Ngayon naman, let us try to compute for the number of molecules. Now, according to Avogadro, who has proposed the Avogadro's constant, according to his computations and experimentations, ang number ng isang molecule ng isang substance depends on the number of its atom multiplied by the Avogadro's constant, which is 6.022 times 10 to the 23rd power. Okay? Now, dalawa na yung ipapamemorize ko sa inyo na triangle. Yung una, for the number of mole, this is mole. This is weight in grams. And this is the molecular weight. The second one is for the number of molecules. Okay? So, in order to get the number of molecules, sometimes referred to as number of particles kasi if we're going to be technically correct, kapag ang isang substance ay bonded covalently, we call them molecule, like water. Kapag ang substance ay bonded ionically, kagaya ng table salt, kasi NaCl ion siya, meron siyang ionic bond, we call them particles, number of particles. Pero for discussion's sake, number of molecules ang gagamitin natin. So for number of molecules, it is the number of mole times 6.022. Ano ang nakalagay sa inyong module? 6.022 or 6.02 lang? Okay, 6.02 lang daw. So para pareho tayo. So 6.02 times 10 to the 23rd power. So kapag ang hinahanap ay yung number of molecules, mole times 6.02 times 10 to the 23rd. Pag ang hinahanap ay yung number of molecules divided by Avogadro's constant. Okay? Hindi naman siguro mawawala yung Avogadro's constant kasi given na yan. So what if we have yung example natin kanina? What if we have 0.1711 mole of NaCl? And then we're going to compute for the number of molecules. Okay, so nawawala yung ating number of molecules. So mole times Avogadro's constant. So 0.11, 17, 0.1711 mole times 6.02 times 10 to the 23rd power. Ang lalabas na dyan ngayon ay the number of molecules. Now, some of you may ask, Sir, paano yung exponent? Sa inyong calculator, ilagay 6.02. Ito yung part na yon. Tapos, paano yung exponent? So, shift log tapos 23 para lumabas yung exponent. That is in typical calculators para lumabas yung exponent. So 0.1711 times 6.02 times 10 to the 23rd power is equal to anyone? Now, in the number of molecules, we will still make use of 4 decimal places. So, gagamit tayo ng 4 decimal places kapag number of moles, tapos kapag number of molecules. So, this will be equal to, wait lang, sa calculator nga ng phone. .03 times 10 to the 23rd power molecules. Do not forget the units kasi incorrect ako ng sagot kapag walang units. Okay, so that is how we compute for the number of molecules. Another example. Okay. Okay, correct. Yung mga sagot. Another example. Ano yung isang kinompute natin na number of mole? Wala. Okay. Another example. How many molecules do we have with 15 grams of potassium chloride? Or hindi, wag na lang potassium chloride. Gawin na lang natin na calcium hydroxide. So how do we compute for this? Grams ang given, ang nawawala ay yung number of molecules. So, tingnan natin yung dalawang triangle natin. This is for the number of mole, this is for the number of molecules. Ano yung in common sa kanilang dalawa? Ano yung common doon sa dalawang triangle na pwede nating gamitin na pang bridge para makapunta tayo from weight papunta sa number of molecules? Anyone? Okay, correct. Si Rose. Parehas sila na may mole. So we will make use of mole na pang gap, pang bridge ng gap between the two triangle. So i-compute muna natin yung mole ng ating substance, which is calcium hydroxide. So in order for us to compute for the mole, it is weight over molecular weight. What is the molecular weight of calcium hydroxide? So si Ca, CO, tapos si H. Ilan ang Ca natin? Isa. For oxygen, dalawa. For hydrogen, dalawa. That times the atomic weight for calcium, it is 40.08. Yung kanina, tama ba? Okay, correct. 40.08 grams per mole. For oxygen, it is 16 grams per mole. For hydrogen, it is 1.01 grams per mole. So this is 40.08 grams per mole. Next, oxygen is 32 grams per mole. For hydrogen, it is 2.02 grams per mole. Next, let us add. So this will be equal to 74.1. Thank you. Grams per mole. Meron na tayong weight. Yun yung 15 grams. Meron na rin tayong molecular weight. 74.1 grams per mole. So what's left for us to do is to divide. So 15 grams divided by 74 grams per mole, 74.1 grams per mole. Cancel grams. So this will be equal to 4 decimal places tayo.
0.2024.
Okay, 0.20, 20, 20, 24 mole. Okay. Meron na tayong number of mole. So, meron na tayong pang-bridge ng gap between this triangle and the other triangle. Now, how do we compute for the number of moles? So, ito yung, how do you compute for the number of molecules? Ito yung molecule. So, mole times Avogadro's constant, which is 6.02 times 10 to the 23rd. So, times Avogadro's constant, so this is 1 point 4 decimal places. Okay, correct. It is 1.2184 times 10 to the 23rd power molecules. Madali lang. So now we know the number of molecules in 15 grams of calcium hydroxide. Paano naman kapag ang given ay molecules? Tapos ang hinahanap ay yung mole. So nandito tayo. Ito yung molecule, ang hinahanap ay yung mole. So molecule divided by Avogadro's constant. Madali lang. Okay, any questions so far? There is a correction in your module number 10 sa may, what do you call this? Activity number 3, test 2, which is calculate how many moles are there in the number of molecules. So for those na hindi nakapansin, dito ko nalalaman kung sino yung mga nagsosolve talaga tapos kung sino yung tumitingin lang sa answer key. Yung iba kasi tumingin lang sa answer key tapos sinulat na. For number 1, so this is module 10. This is activity number 3. Test 2 or part 2. The answers, number 1, ang sagot doon ay 2 moles. Paki-correct yung sarili niyong sagot sa module. Pangalawa is 1.5 times 10 to the 23rd power divided by 6.02 This is 0. Sorry. 1.5 divided by ay, 6.02. So number 2 is 0.0002 moles. Or yung iba kasi kapag sa calculator, ang lumalabas ay naka-exponent siya. So pwede siyang uh, or alisin ko yung ganyan. Or 2.49 times 10 to the negative fourth power. Okay? For number 3, the answer is 564.7841 moles. And then lastly, number 4, it is 0.0001 moles. So this is the answer for activity number 3 ng module 10, yung part 2, converting number of molecules to number of moles. Okay? So, may katanungan pa ba or wala na? Kung wala na, then yes, Erickson.
Sir, dun sa number 3, paano po kung 5.65 times 10 raised to 2 po?
Okay, wait lang sandali. I-compute ko ulit kasi phone yung ginagamit kong pang-calcu. Hindi ko mahanap yung actual calculator ko. 3.4 raised to the 26th power. Okay. So, wait lang. 26 power divided by 6.02. It is 564.784. Erickson, ano yung question mo?
Sir, yung answer, sir, yung lumalabas po kasi sa calculator, 5.65 times 10 squared po.
Bakit naka-square?
Sir, yung parang ganito po sa tawag doon. Never mind na lang.
But Erickson, ko na lang, i-PM mo na lang sa akin, picturean mo, tapos i-PM mo sa akin, and then if you have corrections, i-announce ko na lang sa GC. Okay?
Yes po, sir. Thank you po.
Okay. Thank you. Okay, any other question? What? Kung wala ng question, then last react. Wala na akong maisip na ipa-react. Okay, mag-react ng ganyan, yung may star yung mata. Okay, so for the benefit of all, i-reiterate ko lang, our quiz will be on Friday next week, which is from it's 9:30 to 10:30 ng Friday. Okay, so ang quiz week natin for next week will be Friday. So hindi na siya yung usual na Tuesday to Thursday ng 11 to 12. Mas maganda sana yun para makapag-prepare kayo. Kaya lang, because of the time constraint natin ngayon, hindi natin mai-push yun. Kaya yung quiz natin magiging Friday muna next week. And then after that, after ng quiz natin, yung susunod na week nun is P-Task Week. Once na makakuha na kami ng approval to disseminate the details of the P-Task, isa-send ko sa inyo agad. Okay, so kung wala ng question, I would like to thank all of you. Stop recording na ako. I don't know how to stop recording. Okay, so thank you all sa pag-join sa ating review for modules number 7 to 10. And hopefully, kahit na ganito yung boses at medyo inuubo-ubo ako during our discussion, ay may natutunan kayo at may nagets kayo sa ating lesson or naliwanagan kayo. Yes, may nag-raise ng hand. May nag-raise ng hand? May question ba? Okay, kung wala ng question, so okay, sige Camille. So thank you sa lahat ng nag-join and good luck sa inyong quiz and stay safe. Bye-bye everyone.
Thank you, sir.
Thank you,
Thank you
sir.
po, sir.
Thank you, sir.
Thank you, sir.
Thank you po, sir.
Thank you po.
Thank you po, sir.
Thank you po, sir.